Scene script. Have you ever wondered why the universe exists? What's beyond the stars we see in the night sky? Welcome to a journey of cosmic proportions, where we'll explore the vast and intricate universe we call home. When we speak of the universe, we talk about the totality of all things that exist, from the tiniest subatomic particles to the grandest galaxies strewn across the cosmos, and everything in between. It's the all-encompassing cosmic stage where the drama of existence unfolds. But what are the conditions like out there in space? Well, it's not exactly a walk in the park. Space is a harsh and unforgiving environment. For starters, it's incredibly cold, with temperatures in the shadowed craters of the moon dipping down to negative 250 degrees Celsius. That's colder than any place on Earth. And let's not forget the lack of air. Space is a vacuum, meaning there's no air to breathe, no wind to blow your hair, and no medium for sound to travel. It's a realm of profound silence and solitude. Yet despite these harsh conditions, it's a place of spectacular beauty and wonder, filled with an array of celestial bodies, from twinkling stars and spinning planets to dazzling galaxies and mysterious black holes. As we venture out into the cosmos, it's important to remember that we're not just exploring outer space but also the inner space of our understanding. We're delving into the fundamental questions of existence, probing the deepest mysteries of the cosmos, and trying to decipher the cosmic code that underpins all of reality. Our quest to comprehend the universe is not just a scientific endeavor, it's a philosophical journey that touches on the biggest questions of life, existence, and our place in the cosmos. It's a journey that challenges our perceptions, broadens our horizons, and invites us to see ourselves and the universe in a new light. So our journey begins in this vast, cold, and seemingly empty expanse. But as we'll discover, it's far from empty. As we gaze upon the night sky, we are merely peeking into our cosmic backyard. Our immediate cosmic neighborhood, the solar system, is a complex entity of 8 planets, including our own Earth, orbiting around a star we call the Sun. But let's zoom out a bit. Our solar system is just one tiny speck within the vast expanse of the Milky Way galaxy, which is home to around 200 billion other stars, each potentially hosting its own system of planets. Now let's zoom out even further. The Milky Way in all its grandeur is just one among an estimated 2 trillion galaxies in the observable universe. These galaxies, each teeming with billions or even trillions of stars, span across the cosmos, forming vast networks known as galaxy clusters and superclusters. These colossal structures, linked by cosmic filaments of dark matter, weave an intricate cosmic web that stretches across the entirety of the observable universe. And what lies beyond the observable universe? Well, that's where things get even more mind-boggling. The observable universe is simply the part of the cosmos where light has had time to reach us since the Big Bang some 13.8 billion years ago. Beyond this cosmic horizon, it's believed that the universe continues, potentially infinitely, filled with more galaxies, stars, and planets than we can possibly imagine. But here's the kicker. Despite the mind-boggling vastness of the universe, everything we see, from the smallest speck of dust to the largest supercluster, makes up only about 5% of the universe's total content. The remaining 95% is composed of dark matter and dark energy, mysterious entities that we know exist due to their gravitational effects on visible matter and the expansion of the universe, but whose true nature remains largely unknown. And yet, despite this immense scale, all that we can see is but a fraction of what's out there. Did you know that all known matter, including stars, planets, and galaxies, constitutes only about 5% of the universe's total content? A staggering thought, isn't it? As we delve deeper into the cosmos, we're confronted with 2 elusive concepts: dark matter and dark energy. Dark matter, despite its ominous name, isn't something out of a sci-fi movie. It's a form of matter that doesn't interact with light or any other form of electromagnetic radiation, making it invisible to our current detection methods. But how do we know it exists, you might wonder? Well, we see its gravitational effects on visible matter. Take galaxies, for instance. They spin at such high speeds that they should tear themselves apart, given the amount of visible matter they contain, but they don't. Something unseen, something dark, is holding them together with its gravitational pull. That, dear friends, is dark matter, making up about 27% of our universe. Now, onto the even more mysterious dark energy, a force that accounts for a whopping 68% of the universe. Unlike dark matter, which pulls things together, dark energy does the exact opposite. It's theorized to be the reason why our universe is expanding at an accelerated rate. Imagine blowing up a balloon. Initially, it takes a bit of effort to stretch the rubber, but once it starts expanding, it gets easier. That's somewhat similar to what dark energy does to our universe. It's pushing galaxies apart, causing the universe to expand faster and faster. These concepts might seem a little daunting, but remember, they're just theories, our best guesses to explain the observed behaviors of the cosmos. Dark matter and dark energy are the cosmic detectives most wanted, unseen and unidentified, yet profoundly influential. But why does this matter? Why should we care about these invisible entities? It's simple. By understanding these forces, we can gain a better understanding of the universe and our place within it. They're like the missing pieces of a cosmic jigsaw puzzle, the keys to unlocking the secrets of the universe's past, present, and future. These unseen forces, making up 95% of our universe, continue to baffle scientists, driving us to uncover their secrets. As we continue our cosmic journey, we remain hopeful that one day we'll solve the mysteries of dark matter and dark energy. Until then, the quest for knowledge continues, reminding us of the vastness of the universe and the small yet significant part we play in it. Now let's turn the cosmic clock back to the very beginning. How did the universe come into existence? For decades, scientists have been captivated by this question. The most widely accepted answer comes in the form of the Big Bang theory. This isn't an explosion as the name might suggest, but rather a rapid expansion. Think of it as the ultimate stretch, where every point in the universe moved away from every other point. Around 13.8 billion years ago, the universe was a hot, dense point nearly infinitely small. Then, in an event as swift as it was dramatic, the universe began to expand. In a fraction of a second, it grew from this subatomic size to something astronomically vast. This is a concept known as inflation. But what caused this rapid inflation? The answer lies in the realm of quantum mechanics. Quantum fluctuations, tiny variations in energy, in this ultra-dense point led to variations in the density of matter as the universe expanded. These fluctuations are the seeds of all the structure in the universe today, from galaxies to clusters of galaxies to the vast cosmic web. As the universe continued to expand and cool down, particles began to form. Quarks and leptons came together to form protons and neutrons. These particles then combined to form atomic nuclei. It took around 380,000 years for the universe to cool enough for electrons to bind to these nuclei and create the first atoms, primarily of hydrogen and helium. This was the birth of matter as we know it. And the light from this era? It's still detectable today. We call it the cosmic microwave background radiation, a sort of afterglow from the Big Bang. This radiation provides us with a snapshot of the universe around 400,000 years after its birth, the earliest picture we have of the cosmos. Yet even as we unravel the mysteries of the early universe, we are left with more questions. The Big Bang theory explains how our universe evolved over billions of years, from a hot, dense state to the vast and complex cosmos we see today. But it doesn't answer one fundamental question: what was before the Big Bang? The simple answer is, we don't know. Our understanding of physics breaks down when we try to look back to the very beginning. Time, as we understand it, began with the Big Bang. So it's difficult to even talk about a before the Big Bang, but that doesn't stop us from trying to understand, from hypothesizing and theorizing. There are ideas of a cyclic universe, ever expanding and contracting, theories of quantum gravity, and even the suggestion that our universe could have originated from nothing, thanks to the peculiarities of quantum mechanics. These are all fascinating ideas, pushing the boundaries of our understanding. But the question remains, what was before the Big Bang? Let's delve into some theories. What if I told you the universe could have originated from nothing? This conundrum, as mystifying as it sounds, is the subject of our exploration now. Let's delve into the realm of theories that precede the Big Bang, the point of singularity we've often considered as the beginning of everything. The first one we'll discuss is the cyclic model. This theory proposes that the universe is not a one-time event, but rather undergoes endless cycles of expansion and contraction. Picture it as an eternal cosmic heartbeat, pulsating between periods of intense compression and vast dispersion. Each cycle, called an eon, could last 1 trillion years or more, with the universe repeatedly collapsing into a fiery crunch, then rebounding in a fresh Big Bang. This notion challenges our linear perception of time and presents a universe that is eternally regenerating itself. Now let's shift gears to a theory that takes us down a different, equally intriguing path. Renowned physicist Stephen Hawking proposed a revolutionary idea that the universe could have originated from nothing. But how could something as vast and complex as our universe spring from nothingness? To answer this, Hawking employed the concept of imaginary time, a construct that deviates from our conventional understanding of time. In real time, the universe has a beginning and an end, marked by the Big Bang and eventual collapse respectively. However, in imaginary time, these boundaries don't exist. The universe doesn't start or end, it simply is. Hawking likened this to the Earth's surface. If you start walking, there's no edge where you'd fall off, right? You'd simply keep going, circling the globe. Similarly, in imaginary time, the universe has no start or end. This idea allows for the possibility that the universe could have emerged spontaneously, out of nothing, without the need for a singularity or divine intervention. These theories, however, are not definitive answers, but possibilities, each with its own set of unanswered questions and challenges. They represent our best attempts to grapple with the enigma of our universe's origins using the tools of science and mathematics. They push the bounds of our understanding, inviting us to confront and reassess our notions of time, space, and existence. This journey into the theories of the universe's origin is a testament to our insatiable curiosity as a species. It's a journey that takes us beyond the visible, beyond the known, into the realm of the unimaginable. It's a journey that reminds us of how much we've learned, yet how little we truly know. These theories, as complex as they are fascinating, remind us of our continuous pursuit to comprehend the cosmos. Our understanding of the universe is still evolving, and with each new discovery, we step a little closer to uncovering the grand cosmic story of which we are all a part. The universe, as we've seen, is not only vast and mysterious, but also intricately connected. It's a grand tapestry, woven with an array of cosmic threads that link the smallest particles to the largest structures. It's a network of connections, a cosmic web, where everything from the tiniest atom to the most immense galaxy is interconnected and interdependent. Each element in the universe, no matter how small or large, has a role to play in this grand cosmic drama. A star, for instance, is not just a bright spot in the night sky, it's a nuclear furnace fusing atoms, creating heavier elements like carbon and iron. These elements are the building blocks of planets and life itself. In a very real sense, we are star stuff, born from the heart of distant suns. Even on the grandest scale, the universe is intricately connected. Galaxies are not scattered randomly across the cosmos. They are organized into vast networks called superclusters, interconnected by strands of dark matter. These cosmic structures, invisible to our eyes, shape the visible universe in profound ways. They are the cosmic scaffolding upon which galaxies and clusters hang. But the connections in the universe are not just physical, they are also temporal. The light we see from distant stars and galaxies is not just space but also time. It's an ancient echo, a snapshot of the universe as it was billions of years ago. When we gaze at the night sky, we are literally looking back in time, connecting with the universe's past. Understanding these connections, the physical and the temporal, is key to understanding the universe. It's a never-ending quest, a journey of discovery that spans the breadth and depth of time and space. There are still many mysteries to unravel, many connections to uncover, but with each new discovery, we are weaving our own thread into the cosmic tapestry, adding to our understanding of this vast, interconnected universe. Our quest to unravel the mysteries of the universe is far from over, but every discovery brings us one step closer to understanding our place in this cosmic tapestry.